Welcome, mathematicians. We're going to start our series or unit off with parent functions. Okay, so this is going to be a quick intro, a little bit of review, and then a little bit of new stuff. So, with parent functions, we have a few options here. We're going to ignore this last one called a step function. Very interesting function, but we just don't have time for it right now. Um, this is going to be just a constant function, right? So f of x is equal to c, some constant. In this case, it looks like 1.2 or so. It could be any, but it could be any number. But it's just basically a horizontal line that goes right across our graph. Our next one is going to be f of x is equal to x. So again, this is a parent function. So every time we have an x, it's also equal to our y. So for example, 0, 0, 1, 1, 2, 2, and it also works the other direction. So negative 1, negative 1, negative 2, etc., etc. Next, we have our absolute value function. So basically, it's when when you have a positive number, it's not affected, right? So this portion of the graph is identical, but whenever you put a negative number inside of our absolute value, it turns it positive, right? So in other words, even though we're inputting a negative 1 into our function, our f of x is going to be positive 1. We input a negative 2 into our function, gives us a positive 2. Next we have x squared, which is going to be a parabola, right? So we take a number, we input it, and we square it, right? So in other words, 1 gives us 1, 0 gives us 0. That's not interesting. But 2 gives us 4, right? So we plug in a 2, 2 squared, 2 times 2 is going to give us 4. And if we had a 3 over here, 3 squared, it's going to give us 9. So 3 times 3 is going to give us 9, right? So that's our parabola or x squared function. We also have a square root. It's the same graph, just on its side, right? So if you kind of orient this graph on or this graph on its side, you get f of x is equal to square root of x. So the same graph on its side. And we see that here. So 0, 0, 1, 1. But then now we have to input a 4 to get a 2, right? And if we inputted a 9, we'd get a 3. Okay, so this graph is just the parabola on its side. This is an x cubed function. So we are going to take uh, our points and this time cube them. So 0, 0, 1, 1, and then 2. If I input a 2 in here, it's 2 times 2 times 2, which is not 6. It's going to be 8, right? So 2 times 2 times 2 is 8. So this point is up at 8 someplace. It just continues on up. Okay. And then our last one is going to be 1 over x. Again, in fact, if you put in a 0 here, something interesting happens. You get an undefined function, right? Which is exactly what we have. We have an asymptote here. We have an asymptote right here, not drawn, but we can add that in later. And we're going to talk about this later on in a different unit. But for this graph, it's transformed exactly the same way. Okay, so we have 1. If you put in a 1 here and a 1 up here, we get 1, 1. If we put in a 2 into this function, so we put in a 2, it spits us out a 1/2, etc., etc. And the negative direction, we see a similar thing. So we plug in a negative 1, we get a negative 1, so negative 1, negative 1. And we plug in a negative 2, we get a negative 1/2, so it's right there, etc., etc. So it spits us out this parent function, and we'll see how that transforms later. Each of these are going to have critical points except for I'm going to say this one, but even that has some sort of critical point to it. So critical points are what we're going to kind of focus on when we're transforming these things. For right now, is what we're going to do. Our critical point for whatever c is, let's say it's 1.2. That's our critical point on our y-axis. Sure, why not? Same thing here. A critical point is just going to be our y-intercept. So for right now, it just crosses at 0. We're going to see how to transform that later. And then for right here, this is going to be our critical point. And we're going to move that around for square root of x. We're going to say that's our critical point. That's our critical point. That's our critical point. This one's going to be a little unusual in that this is going to be a critical point. It's where our two asymptotes meet. and we'll focus on that a little bit later again, but just want to talk about transformations for right now. Okay, so thanks for watching this video. I'll catch you on the next one.